Alrighty, my humans, let's go ahead and figure this out. Determine algebraically whether the function g of x is even, odd, or neither. So what that means is I need to plug in negative x. So plug in negative x. Everywhere I see an x. Negative x plus 7. Alright, so let's simplify this. So that means g of negative x. So negative x cubed is negative x times negative x times negative x. Negative x times negative x is x squared times negative x is x cubed, but negative. So that's going to be negative 4x cubed. Negative x times negative x I got x squared, so minus x squared plus 7. Compared that to what we got. So if I have g of x is 4x cubed minus x squared plus 7. The opposite of g of x, which I might have to care about, is negative 4x cubed plus x squared minus 7. See this? That's not the opposite, because it doesn't match that. That's not the same, because it doesn't match that. This would be even. This would be odd. So the answer is neither. So if it matched the same, that would be even. If it matched the opposite, that would be odd. Since it matches neither, it is neither. Neither, neither, nor. And what do we have here? The graph of the basic cubic function x cubed is shown. Suppose that w of x is v of negative x minus 4. Use reference points in symmetry to complete the table of values for w of x. Then graph w of x on the same coordinate plane as v of x and label it. So there's a couple ways I could think of doing things here. What do I want to do? I don't know. So reference points, corresponding points. So the easy part is this one, the minus 4. That's going to subtract 4 from all the y values. So this is going to be negative 4, or 4 if you write it wrong. This is going to be negative 3, and this is going to be 4. The trickier part is this. So when I have that negative there, what that does is that multiplies the x values by negative 1. In essence, what it does is it takes this point and moves it over there. It's a well, I don't know how you want to think of it. It's a flip over a vertical line, is what that is. When we had a negative in front, that was a flip over the x-axis. But since we have it inside there, it's a flip over the y-axis. So this is still going to be 0, because that doesn't go anywhere. This one's going to be negative 1, negative 3, and then negative 2, 4. So 0, negative 4, negative 1, negative 3, and then negative 2, 4, negative 2, 4. And then the idea of symmetry. So since this is an odd function, I'm pondering how I want to explain this. So I'm going to explain it 2 different ways. Other points would be like negative 1, and negative 2, negative 8. So what's going to happen to those is it's going to be 1, because changing the x, and then subtracting 4. 1, negative 5, 1, negative 5. And then negative 2, negative 8 becomes 2, negative 12. So 2, negative 12, which is down here. So then your curve is going to be like this. Now, I said I'd explain it 2 different ways. So another way to explain this part of it in particular is to say, okay, this is the point we're reflecting around, or we're symmetric about. So if we have this part of the curve, the other part of the curve has to be like this. Because this is an odd function, we're symmetric about the origin. We're still symmetric, but no longer about the origin. We're symmetric about where the origin winds up, which is right here. So since I went over up 1, I go over down 1. Since I go over up, I go over down. Because of that symmetry idea, because of an odd function versus an even function. All right, scientists recorded the population of beetles in an area during a 29-month period. The data was plotted, and quartic regression was used to generate the polynomial. During what months of the study were there the most beetles, and approximately how many beetles were there? So the most beetles, it looks like, occurred up in here, so around month 20. And there are approximately, that's 8,000, not quite 10,000, more than 9,000, perhaps 9,800 beetles. And if you get in the ballpark, cool. During what months of the study were the number of beetles predicted by the function unreasonable? Right there. So between, so maybe 3 and that's 7.5, so call it 9. So perhaps, not perhaps between, but between perhaps. So between, I'll just say between, what did I say, 3 and 8 months, because the number of beetles was negative. And that doesn't make any sense. Having a negative number of beetles doesn't mean anything. During which months were the number of beetles increasing? So we were increasing from here to here. So according to the model, I scribbled that out. So that was like, that's 5, that's 7.5, call it 6. So you could say from 6 to around 20. You could also argue, no, I'm going to pick there and call that like 8. So you could also argue 8 to 20 because the 6 to 8 region doesn't make any sense in the context of this problem. What is the approximate average rate of change from the 20th to the 30th? So 20th, we said, was 9,800. And then the 30th, it kind of stops. But I'm going to call it 0 if we continue that trend, 30, 0. So I'm going to do 0 minus 9,800 over 30 minus 20. So that's negative 9,800 over 10, which is negative 980. And my units on that are, that's the population of beetles over months. Beetles per month. Sketch the basic shape of each function on a set of axes given the number of zeros of each function. Quartic polynomial with exactly 3 zeros. So quartic, you could either pick n behavior like this or n behavior like this. You get to choose. I don't think it matters. I did those first, so I'm going to do that. Exactly 3 zeros. So 1, 2, I have now committed myself. Oh, I missed. Make it a bigger dot. 1, 2, 3. So I bounced there. Quintic polynomial, that means 5, with exactly 4 zeros. So you could either have n behavior that goes like this, or like this, or you could have going from here to here. I drew the other one first, so I'm not going to do that one. So I'm going to get rid of, oh goodness, I messed everything up. There we go. And 4 zeros. So 1, 2, 3, 4, 5. So they mean 4 distinct zeros, 3 distinct zeros. They're really 5 zeros. 1, 2, 3, 4, 5. But one of them's repeated. So 4 distinct zeros. So keep in mind, quartic, even. So even polynomials, so even either look like this or like this. Odd either look like this or like this. This would be positive, this would be negative for the leading coefficient. Ask us questions if you got them.